Hello, Happy Jobby fans. We are doing more chemistry today.
Okay, so we have 3.45 gram of the crude. We are going to purify. So first of all, we need to make. We will make the solid loading, and that's why we have to make the silica gel powdery solid load, and we will add here. And there is a stopper. So once we put the silica gel with the solid load, and then we'll put it here, and with the plunger we'll press it down. That is now for our target. So let's transfer these things in a small flask and add the silica gel. And remember that 3.45 gram of the crude. So we are going to use 2 times of the silica, like around 8 gram. Okay.
Oh, it's the same as the column.
Yeah, 8 gram silica gel we will mix together to make it powdery.
Okay.
So let's take it. So I added the DCM here. And I'm going to transfer these things there.
So what the brief overview of this is so you make a solid load with the powder, and then you just load it in there.
Yeah,
In a cartridge.
I'll load it in the cartridge, and after that, that cartridge will be connected to the column directly.
Connected to, okay.
So
And Dr. Fan will show us that part with the actual column itself.
the another person will
Oh, not
show
Dr.
us.
Fan. No, but I wanted Dr. Fan to do it.
Okay, now here is some silica gel I have taken, so you can using the silica gel here.
Yep, double the mass, right? Of the crude.
Yeah.
Or the sample in general, right? This is just crude for
Yeah.
now. Oh yeah, it should be crude, yeah. Because we're purifying. He is cleaning it because he's a good chemist. You don't want to contaminate.
It's also important. Every time if you're using the trap, you have to clean this.
Yes.
And since we are using the silica gel, so you have to put a cotton here while you are drying it, so that it will protect you not to fly away from your flask. But through the cotton, solvent can go, but your silica will not go. So this way.
One time it found its way through the cotton still. And I was
Yeah,
like,
but
what?
That should be like very
Tight.
tight.
Yeah. Wait, should we dump the solvent first? It's not too much.
No, it doesn't. So keep little bit open, Rodobeth, otherwise the whole thing will be pumped out. So initially just let it be go, like the solvent, okay?
Ooh, you fucked up. Or not really us. What happened? So it went beyond the cotton. So we had to stop it. And here we are, trying to get all back down there. Isn't chemistry fun?
Trying to add again. So you will come to know when to open the vacuum. So as long as it has a solvent, it will not bump. Once the solvent is gone and silica gel becomes so thick, in that time it has a potentiality to pump So
It's gonna look like a ring, right? Around.
like not ring, like you'll see like kind of viscous or like,
Yeah.
so you will see like when I'm going to open the vacuum.
Yeah.
As long as there is no bubble, so there will be solvent still, but less solvent, like it is soft with the, like now I'm gonna open it.
Yeah.
So I have opened the vacuum. I will not make too much of the vacuum inside it, otherwise it will be,
Okay. And you just leave it here for a little bit.
yeah, just leave it like this. Okay, so we'll wait until all those silica get like a powdery. So you can see like that is already dried and getting powdery. So once it's done, so I will open this flask and I will use this spatula, scratch out and add those things also in the powder and try to dry more in the vacuum pump. And once it is ready, then I'll pour it in that cartridge. I'll show you.
And you're gonna take this entire thing, right?
Yeah, I'll do it.
Because you don't want the silica gel just going.
No.
Wait, and if anything bad happens to that like line over there and the vacuum or.
So what I'm going to do, I bent it a little bit, the spatula, so that it can easily take out this. So the bottom silica is kind of dry, so it will take out easily those things. And during doing this, don't like tilt too much, otherwise it will be like
fall out. Then you will be sad.
Yeah. I'm just using my dryness silica from bottom, because while you are scratching, those can be a little bit wet with the solvent. So now looks like very powdery, but still we'll do like we'll give some vacuum here, like by using a rubber septa and then with a needle, and then I will dry it. Yeah, we're done. Okay, now we are giving little vacuum here with the cotton in it, so that.
And keep in mind we have this. What is it? The reservoir.
Yeah, and this splash reservoir.
Yeah, and the cotton. We don't want the silica gel.
Yeah, and you see this. This is like kind of free floating powder.
Yeah.
So as long as it is like, you don't need to like keep it like long time.
Yeah.
Just maybe a couple of minutes.
Yeah.
And you will feel like everything is dry. Then you just take it out. Okay, I think it is done. So close the thing. And
Wait, you didn't put on gas at all, right? It was just that.
No.
Okay.
Now I'm just releasing the vacuum created inside. So okay, now
This is the part.
yeah, this is the part. So you have to put the cartridge inside any another flask or somewhere, like, so that it can stay and use it.
Oh, so what do you call that? That white disc on the bottom?
Oh,
is it already
this
there?
is already there by default.
Oh,
But
see.
we will use another one once we put the silica there. Okay.
Okay, we'll see.
So just pour it there.
Okay.
So some of this fruit might be stuck there, so we don't care for that. Now that is done. So use this one. This is called freight. Okay.
Oh,
Put the freight.
Wait, so it comes with two?
Yeah. So this is also separately. They sell separately. So just like this is the crude.
Yeah. Okay.
Okay. And I put the freight and just push with this.
Where'd you get this? This is steak.
They give me this.
Okay.
So go all the way down.
Oh, you want it packed?
Yeah. So done. It is done.
Okay.
So it is ready for now for the
Wait,
color.
so up here it's open, right?
Oh, it is not like this. It is they made
Oh no,
for
I mean,
themselves.
This is open.
Oh, this is open.
Oh, okay.
And they have a certain plunger to go inside.
Oh, okay.
So you don't need to worry about that. But they made it like for themselves to use. But
No.
there will be another plunger for the Combiflash autocolumn, okay?
Okay.
But make sure that you made it like completely dry powder, and then put the frit,
Yeah.
and then push it inside, and it is ready for going for the column. Okay?
Okay.
Let's go.
And cut.
So there are 4 solvent bottles here, like hexane, ethyl acetate, DCM, and methanol. That is for the normal phase column. Okay. So now he is filling more hexane in the 1 hexane bottles, and
We're not supposed to touch that, right? They're the ones
you
in
can
charge.
you can do this. Like if you feel like there is no solvent, so it is better to start with the full bottle,
Okay.
or like sufficient amount of the solvent.
Yeah.
So now he's filling the hexane solvent in the hexane bottle.
Oh, by the way, just a question: is the reverse phase available? Could we use it?
On the other side, but I'm not sure. We need to talk with Dr. Frank. Like, if
Oh,
there
himself.
is-
Okay.
But this is
Yeah, Jill was
clearly
wondering.
dedicated for the
Normal phase.
normal phase. Yes.
Scale of this one?
The crude was 4 gram.
4
So
grams.
is it 10 times or 20 times the silica? Like column.
4 grams, yeah, we can use
40 gram, right?
40 or maybe still 12,
I used before, like always 10 times.
10 times.
Mm-hmm.
So,
To use 40 grams here.
how is the purity?
The I can show you. Is there any marker here? Okay. Yeah, I can show you. So it might have something else, but this is main product, and maybe there's something like this and like this. So this is the product. Polarity is in TLC it is like 10% ethyl acetate, but with the column normally I do 0.5 to 1 or 2% ethyl acetate. Do you reuse the column or like no?
No, we can use this one.
What is it? 25 grams?
Oh.
Normally how much you take? Like double or triple? Because
Usually it depends on the TLC. I mean, if it is relatively pure, if it doesn't have much impurities, usually I do like 12 grams.
okay.
For milligram scales, I always use 4 grams. But if it contains something like this,
Yeah.
several compounds, several products, then probably I can use more.
Yeah, longer, but how about the 40 gram?
Yeah, 40 gram is similar size. It's a little bit thick.
A little thicker.
Yeah, like this.
Oh, okay.
So, what do you prefer? This one or this one? So, which two
I don't know,
is-
like you should, what is your experience? Because I used before, whenever we
This
used,
one.
like we always took like 10 times.
Okay.
So-
So, yeah, we can use this one. 40.
Psilocybin, right?
Yeah.
Is it safer to use the bigger one?
It is
Like
okay.
you-
The only thing is you will need more and more solvent, and it will take some time. So,
Oh.
that's the case. So if you use shorter columns, it means fast.
Save time,
Yeah,
save
but
resources.
it-
Okay.
But like I prefer here like 40 gram because it has like just next to another spot that is also make come
Just so it's
together,
separated more.
Yeah,
Oh,
so-
okay. Okay.
more silica volume is good.
Select this one because
Because
length is
it's
same.
length?
Yeah, it's same. The only difference is the
Mm.
diameter. I don't know.
But retaining property also important for your autocolumn because it is highly pressurized
Yeah.
thing. So this is column, right?
For this one, we use
Is it washed? the plunger?
Usually it will be automatically washed when you are done with the column.
Oh, okay.
So it's
Like they do prime, right?
yeah.
Okay.
You don't need to tight it too much, okay?
Mhm.
So
But making sure not to leak,
yeah,
right?
yeah, yes. You need to-
And even if it starts leaking, then immediately we can pause and we can make a little
Yeah.
bit tighter, right?
Yeah. And so this is the old one, so let's go back.
Do we need to have our own like account or something?
Yeah, let's make
MO SH SH A. Wow.
we need
The file name, right?
Yeah, so let's okay, so it's like this. So when you select from here,
Yeah, it should be silly cycle 25.
Yeah.
Sorry, 40.
Yeah.
It will be 40, right?
it will give you some default
Mm-hmm.
profile, right?
Mhm.
So we can edit this one, right? So make an enter from here.
Okay.
And keep in mind, usually I do not change these parameters, storage like this. So
But if you need to change it because you are using 40 grams, so you
Yeah,
have to
yeah.
change
So-
the 40 gram column.
yeah, when you select this one, it just automatically select
Oh,
all of these
okay,
things,
okay.
right? So only thing we need to change this gradient.
Edit gradient, okay.
Edit gradient. And now we don't need some of these, right? Okay. So what is the profile you need? How much polarity? So
Initially, I want to run the only pure hexane,
okay.
and then slowly it will increase 1%, then 2%, and then 5%.
Okay, so how about the time? So
Like first, maybe 4-minute hexane.
okay. And then you need 1%.
Then 1%.
And how much the time? 15 minutes.
Yeah, maybe. And then
You need to. So you need to increase the gradient,
Yeah.
or just
so like this, then 1%, then
Okay.
2%, and then 5%, like at the end.
percent. So it's 10 minutes. 5%.
Yeah, maybe the end or like 15 more.
50.
Yeah. So if it is not done, then I can continue
Yeah.
for 5 minutes. So
Oh, you can continue, right? Okay. Right. So yes.
Wait, what was the point of the last one? Are they both 5%? The last two?
yeah.
Yeah.
So why did we separate them?
What?
Why was it two different ones? They're both 5%.
It's just you keep the
Keep
Like
constant.
constant,
keep
yes.
constant. Yeah.
each.
Oxygen, acetate, 40 gram.
Yeah, this is 40 gram. So this is the time, right?
Yeah.
And this is the amount, like percentage, right? The ethyl acetate percentage.
It's
Okay.
15 minutes, just the max here. Is that why?
No, you can make more, like if you want to.
No, I'm just
more.
confused on this one. Why didn't we have this at all? Why couldn't we just make this 15 plus 10 or something?
This
Oh,
is fine.
like this is 5% first 15 minutes.
Yeah.
And then again, we are keeping 5% more, like 10 minutes.
Yeah, can
right?
you just have said 5% for 25 minutes?
This one?
Yeah.
Yeah. Yeah, I was just confused why the last row was there. Yeah. Okay.
Okay, so we need
The tray.
yeah. So we don't have that, right?
Oh.
With
no.
the tray. Oh, they. Yeah.
Select the wavelength. Wavelength is already selected, 254 to 80 nanometer.
Yeah, yeah.
But there must be a certain threshold value, like sometimes, right?
Yeah.
So our compound is like kind of very less visible in the UV, but it's visible, but very less. We detect it with the iodine chamber. So that's why I'm saying maybe the peak threshold value should be like about 5 AU or like 10 AU.
It is should
Can
be
you change
around
it?
5 like that, but I don't know how to change that.
Those are there, right? So where is the pen?
Yeah. I'm not sure.
Okay.
Maybe you can try tools.
Okay.
Yeah, I never changed that. Maybe
Here, right? But
no, those are
is there any details? Can I click?
yeah.
Yeah, 0.05 AU. It's fine then. Load based 1 minute. Okay. Okay, monitor. Let's see like what you guys do. I don't want to lose any product.
Okay, so if the machine is not going to click that automatically, we can do it manually. So there is option for us.
Yeah, like, yeah, I understand that one. So, anything else I need to remember? And why we are not changing this column? Size.
Oh yeah, you can do it. Yeah, but we have
Save, right? Oh. Oh my god.
Did we do everything on the 24?
Yeah. So there are two options, insert point and delete point. So if you need more time for any point, so you can easily insert point and you can choose.
Yeah.
And the last option, that is for the amount of ethyl acetate, like
Percentage
what is the
of it.
percentage you want
Yeah.
to use.
Yeah. And you can straight up change the solvents. Interesting. Wait, what are other choices? Is that the DCM? And what else is here?
Methanol.
Ethanol. Okay.
Isn't it like 25 minutes is too, like see one thing, like 0, 0, 4, 0. then 4 to like next point is like will be 1, right? So 25 will be 2%.
So saying for 25 minutes it will be 2%?
Yeah.
Okay. Oh, we're going from 2% to 5%?
So it will not be like stay a little bit time for the. Okay.
So
What does it? No column descent?
English says that.
Oh. Ignore it.
So we can like stop it to pause, right?
Yeah, but so it's kind of
Oh. Okay, okay. I understand. So before starting the sample, this
Yeah.
column will be equilibrated. So
Yeah.
it has a different line.
Mm.
So it is like now equilibrating. So what I used before, the biotage, so that need to be equilibrated first without attaching this. But this machine have like
It's
more
convenient.
good feature that like
So you can just put it
can
in.
add everything, then you can start, then column will be equilibrated. Do you understand what is equilibration? So
but
this
not here,
column
no.
was like dry solid, right?
Right.
So now some hexane only is going through this column. There is a certain volume, like
Yeah.
40 gram. How
Yeah.
much your hexane will require to equilibrate? So machine will calculate automatically. So
okay.
now it is
Telling you.
using that much solvent to equilibrate,
Yeah.
and the time. You will see like it will take the solvent and it will be starting. See, the solvent is very clear.
Whoa.
So the graph will be automatically here, right? Yeah, see, you can see.
Oh wait, it already finished the first one? First
No, no,
two?
no. Like it will collect like if you say see anything.
Yeah.
So it doesn't matter like if there is the compound. But if you see something is already moving.
Yeah. No, I'm just confused. Why is it? Why did it move to the second two?
First one is kind of
Yeah, kind of blank.
Blank. Okay.
But if you look on the screen now, so you'll see like couple of wavelength will be moving through this. Like just started, see there. Right? You see that, right?
Yeah.
The red line.
Okay.
So ultimately this compound is moving like this.
Yeah.
Now since it is started, if I need to make a pause, like where I can click.
The pause button? Does that work?
this one.
Okay.
Wait, the stop?
Yeah.
Wait.
No, I think
No, it's
this
not,
one,
it's
this
not.
one.
Pause. Yeah.
This is pause, not this one.
Wait, the square is the pause.
Yeah.
Oh.
This is
So we never
Are you
have.
sure?
yeah, yeah, yeah.
Oh.
And from this one you can control the collection. So for example,
Oh, yeah.
So if we pause it, we could just play it again right after, whatever.
yeah. Now it's pause,
Okay.
not stop.
Oh, okay.
And you need to
We just play it again. Okay. So the pause symbol, just don't worry about it.
Yeah.
Okay, gotcha.
Yeah. And if you think like now machine will collect only the peaks, so it will collect the peak once. It will see some reactive peak, then it will start collecting. Otherwise, everything will go to the waste.
Oh, it dumps
But-
automatic.
But
Yeah.
suppose you have the LFP compound,
Okay. Oh, yeah, yeah,
okay,
yeah. Yeah.
and maybe it might have some carbonyl group, but not
Yeah.
too much of the UV active, and you're not sure like whether it is collectible or not. But you want the fractionation.
Yeah.
So you can do it, but in that case you say all, collect all. So it will collect all in every test tube, and then later on you can just do with the iron chamber. But
And this
it will
time
be
we
like-
specifically said peaks only.
Yeah, it's
Being convenient for us. Okay. Oh, peak. How does it go? Does it stake around? Okay. That's so cool.
Sometimes this one is kind of overflow.
yeah.
What if it's too polar? You said?
Yeah, if it is too cold.
Oh, okay.
This one can dissolve the color.
Yeah,
So
and
you
it can start
block
overflow.
the bathroom.
Oh.
So this one will put it outside. And go like this. Upper tube, so it will overflow.
Oh.
So there is
Okay.
So especially during choosing the solvent,
Yeah.
what kind of solvent you want to run from the beginning.
Yeah.
that case we
So you're saying your compound can't be significantly more polar than the solvent? So just
so it's not from
yeah.
Yeah.
Oh. Okay. You don't want that. Yeah. Okay. Oh, okay. Thank you. So what am I looking at here? Why are they? There's one red one and one blue. Is that blue?
There are two wavelengths. It is
Yeah.
254 nanometer and
Oh.
280 nanometer.
Okay.
So if you have the multi-print, so definitely you will get 254 nanometer and 280 nanometer.
Yeah.
wavelength. So it is just measuring two different wavelengths. That's it.
To
Same
be safe.
compound.
Yeah. Okay.
Whatever it is, maybe it is the impurity, like top part. So now, if you see like something is going down.
Going over into.
No, yeah. If you look on the column, see like it is kind of more whitish than this.
Yeah.
So something in the compound. So once it increases the like polarity, then it will start moving quickly because now we are running just hexane because of this additional top spot to be out for the with the hexane. And also with the hexane, then it will start moving a little bit. And now. And I want to shorten the hexane length. What I need to do then? Like now they're running, right? So
you need to
hexane-
edit the method. That is
yeah, edit the method during the
While it's running.
yes.
yeah.
Oh, always.
Yeah, you can
Okay.
In most of the cases, I have seen some people they use a palette.
Oh wait.
Yeah.
So go back to the method editor, and then what did you click on to go back to the screen?
The exit.
Just say exit. Oh, okay. And this is the default screen.
Yeah.
Okay.
When it is running.
When it's running, yeah.
Oh yeah,
You can
yeah.
see-
We will know like which one is where,
Yeah.
right?
So you can see these color codes,
Yeah.
the blue color like that. So you will see different color codes for similar type of fractions.
Yeah.
Then you can color these systems.
Are we required to be here to monitor this?
No, not all time. You can start and you can go on. But if you know that will be your enough time and solvent. Because sometimes you give the gradient and half done but still compound is not there.
Yeah.
So based on your experience with the similar kind of compound you did before, then if you know that like point to point you start. So you can use the same method you did before. So since we are doing just now, and I know the TLC is like that, so I'm a little cautious. That's why I use like more silica plus also the polarity,
Yeah.
right?
Let's check this one, whether it is overflowing.
Yeah.
Because you can see the solvent level is increasing like this. So
Okay, and who ordered those things normally, the column and those cartridges?
I'm sure it's good. So
Or
it's still
is there any way like we can be charged like whatever the amount that things we are using from here?
I'm sure.
Because
Sure.
okay,
He is the person who
Dr. Fan.
Yeah, who is holding all of this stuff. So,
Okay. PSI to 200 PSI max. So pressure should be like around 15 to 200 right? Yeah.
column for compound.
Yeah.
Why don't you have pack that same thing, right?
No, the apparatus you can also use
You
it.
can-
Same way.
Yes. When I maybe use 10% maximum.
It's less
For polar compounds, I use up to 80 or 70% maximum. So usually I don't use this gradients. This is much simpler version.
Yeah.
Wait,
Most of the cases it works.
wait, how do you set that then? You said
Oh,
you don't
you can set
the
similar
similar
doses, gradient edit. Remember you was
Yeah.
in the time.
Same thing.
So you can do this like you can increase the polarity and decrease the time. Then you'll see like that.
No, yeah, we're doing it more like
Yeah,
like
we're,
this, like a staircase. Oh, okay.
This is kind of similar to the manual columns. So just increasing the tolerance.
Oh, okay.
Because here you do have some intervals. So
Yeah.
like this.
So there might have here might have a UV
Yeah, wait, where is
detector
where is the detector?
inside. Definitely inside this one. Yeah. So that detector will detect like detector is like an eye.
Yeah.
So it will detect like your
Oh,
compound
oh,
is
oh.
passing through.
Oh, yeah,
Then
well,
it will show you the peak.
Once it goes through the column.
No,
like
not
that-
goes through the column. Once it is eluted from the column,
Yeah, I'll
so it will immediately go through the UV detector.
Yeah, so
And
after
then
it
you will
goes-
see once the UV detector get your compound, then you will see a band like that.
Yeah, okay. Okay.
So this kind of instrument requires actually you need to know where it is where the options are where, like what are those. So individually, if you look here, like file, method for editor, tools, help, and then here like zoom in, format graph, no column, insert point, delete point, visible, and run length is like 66 minutes. So you can also edit the time. And here like you can pause this running by clicking the square, like this is square, not this one. So if you want to click it, it will be like paused or like stopped, and you can then you will get a like a triangle shape there. Then you can, if you re-click it, then you get the system started again. And this is actually like suppose your fraction collector is start collecting in one test tube, and if you click there, then it will automatically shift to the another test tube. That means if you want to change the next test tube, like suppose you collect certain amount of the compound in a certain test tube, and immediately you want to manually to say like, hey, go to the next test tube. So you will click this one, then it will start collecting. And these options, forward-ish options, and very important options is here, like all peaks and none. So right now this method is going on just to collect the peak wise. Like once it will get any peak, then it will start collection. Otherwise the collector is stopped, like it is not collecting anything right now. So that's why like the option is peaks. But if you choose the option all, then it will collect all, no matter what, like whatever the solvent passing through this column, it will be collected everything in this tray, even if it doesn't see any peak or anything. So that is also sometimes helpful for the aliphatic compound, or like if you want to know, if you want to do the fractionation by column, and you can determine by TLC with the iodine chamber or something, so it might be helpful for sometimes, like by using all the collection. And none means like nothing need to be collected. So normally people doesn't choose the none. So these peaks are all this one. And here it is showing the sample name. So this sample name will be saved as a today's date, but if you want, you before starting you can put your sample name here. And the silica gel column, what is the size of the column you are using, it can before it started you can choose it, and accordingly you can make the gradient. The gradient is this, like now we are running first like 20 minutes pure hexane, then now it is running 1% ethyl acetate in hexane, then it will be like 2% ethyl acetate in hexane. So that's how it will start working. So now it is actually 1.2%. So this gradient will work like this, like it will increase the polarity slowly by 0.1. And the solvents are hexane and ethyl acetate. Solvent A hexane, solvent B ethyl acetate. And definitely you can go to the method editor if you want to change any that's gradient, shortening the time or increasing the time, or shortening the polarity, decreasing the polarity or increasing the polarity. So you can do it by clicking the method editor. So yeah, that's pretty much the machine. So if you know all those options, then it will be more easy. So while you are free and not doing anything chemistry or anything, but you want to play around, so just play around those things, but be careful. This machine is really sophisticated. Don't do any weird things with the column or like this side. So maybe without column or like with the connector, just you can see, and do not run anything. Just you can see like what are the options, where is it found, like what is available. So in that way you will be like more used to this interface, and you will feel more comfortable to use this. So this is like almost everything for this Combiflash column. So now we are we are running our sample through this column. So very soon we are expecting our compound will be coming or diluting. So we will show more once it is collecting. So yeah, keep watching this video.
Maybe record.
It will start very soon, I guess.
Ooh. Is some,
No?
there is something. Oh no? Aha! It's collecting.
Yes.
Wait, is this our product?
I don't know, maybe.
Wait, what is this looking like? Where's the... Oh, the white is still above. I don't know.
Or maybe kind of impurity, because still it has something. So let's see. Actually.
I can't even... The peak just went black. It went down right away.
Yeah, maybe that is not the compound.
Oh, it's not it. False alarm. Gotcha.
alarm.
Trolled ya. It's a prank.
I'm not. So if you want to stop the experiment when it is running, just you have to click this forward button, then it will show you earbud. So click the earbud, then it will do automatic earbud, and it will be ending the process, and it will wash, all wash progress and earbud progress like for 30 seconds. Also the amount of the percentage of solvent. So by this way the machine is getting preparation to stop knockout experiment. Yeah.
Green color maybe.
Yeah, so the blue, green and the red. So most probably blue is the compound.
This one. So then
Green.
3, 6, 9, and so then 12 tubes. This green one.
You're done, right?
Yay.
So now I will be opening first this one,
Let's see.
and then this one, although it has some solvent.
So you
Here.
no, not like that. Just, yeah.
Oh.
Yeah. And then press it and open it. Like you have to press this and rotate it.
No, just no.
Oh. Okay.
So then put it there. Do you need it up?
So you just raised it.
Yeah, just
Oh, it was that easy.
Okay, now
yeah. It will be a little bit tight, but you can handle everything like smoothly and carefully, you know. And
Wait, what
this-
is that?
There is another extra needle, so you have to just keep it like so that it cannot go down.
Just so it's stable.
Yeah.
Okay.
Yeah, just stable.
Okay.
So this
okay, now
column.
you can take instruction.
Okay, so everything is done. So if it is done, so we can leave it like this, or
Yeah.
Wait, how do we save this data?
it will be already saved according to the method. So you can later on you can open it in your name and method.
Wait, but where do you go to access it?
Yeah, that's a good question. So
You usually. So what I'm doing is I'm just taking a snapshot of this one.
yeah,
So otherwise, I think you can save this data in your folder somewhere.
Okay.
Yeah. Yeah.
there are lots of options. Like
Yeah.
you can save your run as a PDF, save run as a text, import method, export method. So you can use this method again for the new analysis, and also save method as. So you can save your method in your folder. Like what is the name?
Usually
So-
I'm not saving the results, I just take the snapshots.
Yeah. So normally it is enough. Like, and you know already, like what is the solvent polarity you might need, and
Yeah.
where is your compound, and which fractions you will get it. So
Yeah.
how
I think
long you
you-
did it. So every information is in there. So that's why you can redo the method. So it's not a big
Yeah.
deal. Okay.
And you can just take a picture too.
Yeah. And yeah, it is important. Like sometimes you may forget like where was that point, like the color code. So before finishing your things, just take a picture. But then you can know where is the product or something. Okay. So how about this? Like
You can discard that one, but in this case, still not sure of the product, right?
Yeah, yeah.
Just keep that. This one is information.
yeah, maybe it is better. This too. Do you have this step or like you?